We want to demonstrate practical the way it should be done. 2021 NECO trial question number 3, part 3. This is the circuit diagram of the question. You are provided with an ammeter, a key, resistor box, 7 connecting wires, 2 cells, and other necessary apparatus. This is resistance box. This is resistance box. This is 2 ohm resistor. This is voltmeter. This is 2 cell. 1 cell. The second one, when it is more than 2, when it is 2 or more, we call it a battery. This is the key. Everything is available inside the circuit board. So now, number 1, measure and record the value of EMF. Connect the circuit as shown in the diagram above with R is equal to 0.0 ohm. Close the key. K, read and record the value. Setting R is equal to 1.0 ohm. Close the key. K, read and record the potential difference from the voltmeter. Repeat the procedure for 5 other values of R is equal to 5 ohm, 10 ohm, 20 ohm, 40 ohm, and 60 ohm. Calculate your readings. Plot a graph of VR against R, starting both axes from origin. Determine the slope S of the graph and intercept C on the vertical axis. 8. State 2 precautions you will take if you are to perform the experiment in the laboratory. 9. What is meant by the EMF of a cell? 10. A battery of unknown EMF has internal resistance of 2 ohm and external resistance of 6 ohm is connected to the cell of the PD across the 6 ohm resistor. Resistor is 9 volts. Calculate the EMF of the battery. Now, the first thing is that we should take the reading of EMF when the resistance is 0. When all the buttons are available on the resistance box, the resistance is 0. When we close the key, the value of E is, when we close the key, the value of E is 3.0 volts. Now, we are going to remove 1 ohm. When we remove 1 ohm from the resistor box and close the key, the value of voltmeter is 1.3 volts. You switch off, replace the key, then the next one is 5 ohm. You remove the button of 5 ohm from the resistor box. When you do that, close the key again. The value is 0.9 volts. Then you switch off, replace the key. The next one is 10 ohm. Replace the button on 10 ohm from the resistor box. Close the key again. The value is 0.4 volts. When you open the key, replace 10 ohm. The next one is 40 ohm. This is 20 ohm. This is another 20. 20 plus 20 is equal to 40. Close the key. The value is 0.2. 20. value is 0.3. Now switch off, close, remove. 20 plus 20 will give us 40. The value is 4.2. Then 60 ohms. Replace 20. This is 50 ohm and this is 10 ohm. Switch it on again. The value is 4.1. Now, the inverse of 1.3 is 0.769. The inverse of 0.90 is 1.111. The inverse of 0.4 is 2.5. The inverse of 0.3 is 3.333. The inverse of 0.2 is 5.000. The inverse of 0.1 is 10.000. Let's plot the graph. We are going to plot the graph now. We are directed to plot V inverse against resistance. So the maximum value in V inverse is 10. The minimum value is 4.77. As I told you the other time, when you are plotting, you plot to 2 decimal places. So we are going to plot 1 against 0.77. We approximate 91, add it to 6. We are going to plot 0.77 against 1, 1.11 against 5, 2.50 against 10, 3.33 against 20, 5.00 against 40, 10.00 against 60. Now, the reasonable scale we can choose here, since the maximum is 10 and minimum is 0.77, is 1, 2, 3. 10 small square to represent 1 foot. So, to represent 1 foot under V inverse, and under horizontal scale, the resistance 10 small square will represent 10 ohm. 10 small square will represent 10 ohms. Now, we are going to plot, when you have 3 decimal places like this, we are going to plot to 2 decimal places. When you have the third figure to be 5, 6, 7, 8, 9, you approximate it to 1 and 9 to the second one. So we are going to plot 2.77 against 1. So this is 0.77, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So 0.77 will be around here against 1. So it will be here. 1.11 against 5. 1.11 is here. This is 1 here. This is 1. 1.11 against 5. 1.11. 1, 2, 3, 4, 5. This is here. This one is here. 2.5 against 10. This is 2.5. 1, 2, 3, 4, 5 against 10. This is 10 here. 3.33 against 20. This is 3. 1, 2, 3. 3.33 against 20. It will be here. Then 5 against 40. This is 5. This is 40. 5, 40. 10 against 60. This is 10. This is 60. Then we are going to join them together, making use of this ruler. It will cut 3 points conveniently. We call this one, also call this. We have our intercept to be here. Our intercept to be 0.2 and the vertical axis. Now, let's calculate the slope. Let's draw a right angle triangle, a big right angle triangle. That's it. So, then y2 is equal to 10, y1 is equal to 0.77, x2 is equal to 60, s1 is equal to 0.77, s2 1.760 against 1. Let's use this. Let's use this. That will be 60 minus 1. So this one will give us 10 minus 2.78 divided by 60 minus 1. This one will give us 9.23 divided by 59. This is equal to 0.156. The intercept on the vertical axis is 0.2. 0.2. Precautions here are noted and corrected serial run of voltmeter. Number 1, number 2 are ensure tight connection and clean terminals. B1, you are directed to define electromotive force. It is the total energy available in the cell. Then you are directed to find the electromotive force in this diagram. Directed to calculate the electromotive force E. That's what we are looking for. We are going to calculate I also. R is equal to 2 ohm. External resistance is equal to 6 ohm. Is equal to 6 ohm. To calculate I, V is equal to IR. Our V is 9 volts. Our I is this. And our R is 6. So I will be equal to 9 over 6. It is equal to 1.5 ampere. So now slot in I, R, small r, and capital here. E will now give us 1.5 bracket open 2 plus 6. That is E is equal to 1.5. 2 plus 6 is 8. So E is equal to 1.5 times 8 is equal to 12.0 volts. So electromotive force is equal to 12.0 volts.